1, 0.
Uno, dos, tres, cuatro.
Hi everyone, today we're going to take a look at 3.3 division of polynomials, and we're going to revisit some stuff that you did way back in elementary school. Think back to what we've learned in Math 9, and if you take a look at our first example right here where it has 15x cubed plus 5x squared plus 10x divided by 5x. If we asked you to divide that trinomial by that monomial, we'd be able to do that, and we can do that because our denominator, the 5x, it's divisible by each of the individual terms on top. So you can look at this in several ways. You could factor a 5x out of the numerator as one option. And if you do something like that, then we'd be left with 3x squared plus x plus 2. And because you have a factor out and you have a 5x right there, they can reduce with each other, and you'd be left with just 3x squared plus x plus 2. If you wanted to, you could also individually give the 5x to each of those terms, and you'd end up with the same end result. So back in grade 9, we've done things in which you've been able to reduce polynomials and divide polynomials by each other. But if you take a look at some of the examples coming up, including this next one right here, it's not going to be that straightforward. So think about this next question. How do we divide a polynomial by something more than a monomial? So if you look at that, we have a binomial on the denominator, and if we wanted to reduce something like this, well, that would look potentially familiar from some pre-calc 11, where you could factor the numerator and then see if you have a common factor that you could reduce. And so if you said, okay, well, what are two numbers that times to negative 24 and add to 5? It could be x plus 8, x minus 3 over x minus 1. And in the past, we would have something in which we'd have a common factor that we could reduce, but in this case, there's no common factors. And so if we have no common factors, there's nothing more we could do as of right now to be able to simplify it. And so the question then becomes, are we able to divide a polynomial by something like what we have right here? And can we simplify this, or can we express this in another way rather than just simply trying to factor and seeing if it would reduce or not? So the answer to that is we are able to do more. And so today we're going to look at two methods that are going to allow us to do that. There's long division and synthetic division. And for long division, that's a word that you may have not heard of in, I don't know, maybe the last 5, 6, 7 years. And so let's quickly refresh ourselves in terms of what we know about long division. So take a minute right now. If you had 5 and you're dividing that into 3,418, how many times does 5 go into that number? Take some time. Do you remember how to do this? So I'm not sure if we learn this the same way, but you would take the 5 and you would say, well, 5 doesn't go into 3, but 5 does go into 34. And 5 goes into 34 6 times. So I'm going to write the 6 on top right here. And then underneath that, 5 times 6 equals 30. You could subtract that and you get 4. And what you want to be able to do then is you want to carry down a number. So you carry down this 1 right here. And you would then repeat the same process until you've used up all of the digits in what we're going to call the dividend. So 5 goes into 41 8 times. And 5 times 8 is 40. And we subtract that, and that leaves us with 1. Carry down the 8. And 5 goes into 18 3 times. And we have a remainder of 3. Okay, so kind of a strange, I don't know, throwback to some years before, but this is the skill that we're going to have to be able to use for today's lesson. Okay, let's go through some terminology. on top, what we get as our solution from having done this division is our quotient. So in this case, 683 is our quotient, and our remainder was 3. And I know two terms that I always get mixed up is what's the difference between the divisor, and the dividend. So we're going to say there's our divisor and this is our dividend. So our divisor is 5 and our dividend is 3,418. Okay, so you're not going to have a ton of those questions on your next test, but we will be able to now apply that to questions with x's. I almost want to call a timeout right now and just say these first two examples, they're good, but you might want to take a look at maybe even an additional example before we get started on these two. Let's do this right now. If you go onto the side right here, let's see, wherever you have some space, I'm just going to write out an additional question, and I just want to see how we could do with something like this. If you had, let's do it on the side here, x minus 2, and x minus 2 is going to be divided into, let's say, 2x cubed minus 3x squared plus 2x minus 5. Okay, and we're going to try to divide using a long division right here. Okay, so here's how it goes. You compare the x minus 2, and that's a binomial, with two terms in the dividend. So we'll say it's 2 on 2, 2v2. So x minus 2 is being compared with 2x cubed minus 3x squared. And you say x times blank equals 2x cubed. X times 2x squared is going to equal 2x cubed. And so whatever you get for an answer, you write right down here. And then we distribute what we put as our start of our quotient. So now you would say, okay, if I did x times 2x squared to write 2x cubed, I now do negative 2 times 2x squared, and that's going to give me negative 4x squared. And 100% of the time we subtract, and 100% of the time our front terms will reduce with each other. And then you'd be left with negative 3x squared, subtract negative 4x squared. We're subtracting a negative. And when you subtract a negative, the two negatives turn into a positive, and you would get negative 3 plus 4, which is going to give us x squared, and then bring down the 2x right here. And we repeat the exact same process. So you're going to say x, your front term here, x times blank equals x squared. X times positive x does that. And then you're going to distribute the x that you put on the top as part of the quotient, just like you did with the 2x squared before. So we would say, okay, now x is going to be times here, and x is going to be times here. X times x gives us x squared, and negative 2 times x gives us negative 2x. We subtract. 100% of the time, our fronts cancel out. 2 subtract negative 2 is like saying 2 plus 2, so we get positive 4x, and then we carry down the 5. So we have 4x minus 5 down there, and you would say x times blank equals 4x, x times 4 equals 4x. And then negative 2 times 4 gives us negative 8. We subtract that right there, and we get a remainder of 3. Okay, definitely one of the stranger questions you've probably done, but that's how long division works, and that's going to help us now when we get into our next two additional examples. So one caveat, if you're writing this out and you have something in which we look at this first example, it says 3x cubed minus 2x squared plus 1. there's an x cubed term, there's an x squared term, but there's no x term, and that's a placeholder, and we need to make sure that that gets represented. And so that's true for the dividend and for the divisor. Anytime that you're missing some sort of placeholder where there's 0 x's in this case, or 0 of whatever it is for that that degree, you have to make sure that you fill that in as being 0 of that when you do your division statements. So here we go, we have x minus 2, and that's going to be divided into 3x cubed minus 2x squared plus 0x plus 1. And think back to what we just did in the previous question. We're going to play 2 on 2 again, and we want to see what this would look like as we go through this. So you would say, well, x times blank equals 3x cubed. X times 3x squared equals 3x cubed. And then you distribute that, and you would say negative 2 times 3x squared would be negative 6x squared. Draw a line, subtract. Negative 2 subtract 6 is going to give us positive 4x squared. Bring down the 0x, and we're going to repeat this process where we play 2 on 2 again. X times blank equals 4x squared. X times 4x equals 4x squared. And then we would say 4x times x and 4x times negative 2. So we would get 4x squared minus 8x, subtract it, cancels out, 8x, carry down the 1. X times blank equals 8x, x times 8 equals 8x. So we get 8x right there. Negative 2 times 8 is going to give us negative 16. Subtract it, and that gives us a remainder of 17. You may need to pause, rewind that, look at that a little bit more. Once you get it down, you'll know that you have this down. But until then, I know it's a little bit complicated sometimes. Okay, so if you're feeling good about that, I would pause the video right now and I would try the second example. Just be aware that if the first example and the one we did even before that was comparing 2 on 2, this would be comparing something 3 on 3. So give it a try, and make sure that when you rewrite the dividend, you'll see that note at the top there, you always have to write it in descending order. So right now it looks like our dividend's out of order because we have an x to the 4 followed by an x squared followed by an x cubed. That's not in the correct order, so you always want to make sure that you rewrite that first when you place that there. So here we would say something like x squared minus 2x plus 3 3x to the 4 plus 2x cubed plus, minus 5x squared plus 0x minus 1. Okay, so 3 on 3. X squared times blank equals 3x to the 4, and that would be x squared times 3x squared is going to equal 3x to the 4. And then we distribute it, and we would say, well, what would happen now if you did negative 2x times 3x squared? You would get negative 6x cubed. And then 3 times 3x squared would be plus 9x squared. We subtract it. Our first terms cancel out. 2 subtract negative 6 would give us positive 8x cubed. And then negative 5 subtract 9 would give us negative 14x squared. And then you carry down the 0x. Then we repeat the process, and you would say x squared times blank equals 8x cubed. So x squared times 8x. So we'll write that at the top right here. Negative 2x times 8x would give us negative 16x squared. and 3 times 8x would give us plus 24. We get 2x squared, then we have 0 minus 24. Carry down the 1 right there. And you'd say x squared times blank equals 2x squared. So you'd say plus 2, 2x squared. And then you'd say negative 2x times 2 is negative 4x. And 3 times 2 is 6. Subtract that, and you would end up with negative 20x, negative 1 minus 6 minus 7. So one thing that's going to be new to this question is your remainder is going to be a binomial, and that's okay. You're allowed to have a remainder that says more than one term, especially if you are dividing it by a trinomial right there. Okay, as we continue on, what's going to start happening is there's actually an additional way, aside from long division, to be able to also do these operations, and that's using something called synthetic division. And synthetic division has the huge advantage of being much more efficient in being able to do this. So if you're saying, wow, I felt like I had to do 20 mathematical operations to see if I could get that one right answer, you're going to find that things are a lot cleaner when you do synthetic division. So let's look at a couple examples in which we could do something with that. Now there's multiple ways to teach synthetic division, so this is just one way, and this is the way that that I use, but you may have learned a different way in class or with a tutor. So here we have something which we're dividing by x minus 2, and we could say, okay, well, x, whoops, sorry, let me not actually write this. When we do synthetic division, we're going to set up something that looks like this, sort of a sideways L. And with x minus 2, you would say that its solution that it would produce if it was x minus 2 is equal to 0 would be a positive 2. That would be its solution. And we're going to write each of the coefficients that we have along the inside here. And if there's something in which we have 0 x squareds, because we had 5x cubes, but we had no x squareds, and then we had 1x, we have to make sure that we continue to represent that as well. So our coefficients would look like this. Okay, so I think the best way to do this would be just to go through an example, and then we can talk about why that worked after. Let's carry down the first term 100% of the time. Step number 1, carry down the front term, and then we multiply right here. 2 times 2 is going to give us 4. Then we are going to add the values that we have here. Negative 5 plus 4 is negative 1. And repeat that exact same process. So 2 times negative 1 is going to give us negative 2. Add that together and we get negative 2. 2 times negative 2 is going to give us negative 4. Add that and we get negative 3. And then 2 times negative 3 is going to give us negative 6. Add that together and we get negative 10. Okay, so if we have something like this, what are we left with? It's kind of a strange looking solution. But what we have right here are, that's our quotient, and they're the coefficients to our quotient. So starting at the very back with this negative 3, that's going to represent our constant, and then we're going to work our way up. So that's going to be our x term, x squared term, x cubed term. So we could actually say that our quotient is going to be 2x cubed minus x squared minus 2x minus 3 with a remainder of negative 10. And hopefully you're saying, that's all? We just saved a bunch of time doing that. And so you'll now be able to say for many questions, you'll be able to do synthetic division instead of long division. A couple things to talk about. One thing is there a way to be able to do a check? Do I know if I've done this right? If I'm writing an assessment and I look back at this and I want to know, do I have the right answer? You could think about your different division statements. And I know we glazed by something before that had something with that listed. But if you said a question like this, if we said 5 goes into 34 6 times with a remainder of 4. We could rewrite that statement by saying 5 times 6 plus 4 equals 34. And another way of saying that then is saying, well, 5, that represented the divisor. So you could now say, well, I know that my divisor times by my quotient plus the remainder is going to equal the dividend. And that's something that we can now start to use more and more and more. And so if you wanted to do a proper check of this, you could say, if I take x minus 2 and I times it by my quotient of 2x cubed minus x squared minus 2x minus 3, and I add the remainder of negative 10 to that, I'll come back with the original statement of 2x to the 4 minus 5x cubed plus x minus 4. Okay, let's try a couple more examples. This next example here may look familiar, and hopefully we'll be able to say, hey, we can do this way faster now. So 2, our coefficients are 3, negative 2, 0, and 1. Drop down the 3, times those 6. We add for synthetic division, you get a 4. 2 times 4 is 8. Add that. We get 8. 2 times 8 is 16. Add that, and we get 17. That back value is our remainder. Our remainder is 17. And our solution will be 3x squared plus 4x plus 8. So think about that question and then scroll back up to a couple examples ago and think about how much faster we did the example we just did than we did example 2a right here, because that was the exact same question. Okay. Now we have something here where we're dividing by x plus 3, so we'll write negative 3 on the side here. Open it up and we'll say 4, 0, negative 30, 0, negative 50, and 2. Bring down the 4, negative 12. We add that, negative 12. Negative 3 times negative 12 is positive 36. Add that, we get 6. Negative 18. Add that, negative 18. Negative 3 times negative 18 is going to be positive 54. Add that, we get 4. Negative 3 times 4 is going to give us negative 12. Add that, and we get negative 10. This is our remainder. And our dividend will be 4x to the 4 minus 12x cubed plus 6x squared minus 18x plus 4. Okay, so once you get that process down, I'm assuming that you're going to find that a little bit easier than some of our long division questions. So let's move forward and see what else we can see here then. So example 6 and example 7 are two additional synthetic division questions with a twist. So if you were to treat this question, example 6, just as what we've done before, let's do that and then let's see what we may have to consider at the end of this. So if you're dividing by 2x minus 1, my guess is you would say, well, it makes sense to put a 1/2 right here on the side. And then we would have 6, -7, 4, -11, and 9. And we do the exact same process. Half of 6 is 3. We add that and we get -4, -2. We add that and we get 2. Here we get 1. We add that together, -10. And then half times 10 is -5. We add that together and we're left with 4. So it's a pretty straight process. And as you start to take a look at that, you would say, well, now let's see what we would have if we were to do a check with this. So think about back to that division statement. And if we were to put together a division statement for a quotient that had 6x cubed minus 4x squared plus 2x minus 10 with a remainder of 4, we could say, okay, well, that means that my divisor, 2x minus 1, times by my quotient of 6x cubed minus 4x squared plus 2x minus 10 plus my remainder of 4, that should be equal to my dividend, my original. And there's an issue with this, because if we were to do that and you did a bunch of expanding right here, then right away you would see that you were doing 2x times 6x cubed as your first operation, and that would give you 12x to the 4. And we know that we can't have 12x to the 4 as part of our statement because we're beginning with 6x to the 4. So the quick and easy is this, and I want to see if we can make sure we can do it, and then we could talk about it after. The 2x minus 1, if you have a leading coefficient like we do right here, we have to divide by the leading coefficient at the end. This 6x cubed statement, we're going to divide all of it by 2 because of the leading coefficient, and we're actually going to now say our official quotient is going to be 3x cubed minus 2x squared plus x minus 5. The remainder remains unaffected, but that will be our final solution. And if you did a check of that, you would find that that does work. So the reason that that happens is because when you have 2x minus 1, it's actually, the way we're treating it is we're factoring out a 2, leaving us with x minus 1/2. And then we're taking that 1/2 and we're using that for synthetic division. But we know that saying something like 2 bracket x minus 1/2 is different from just having x minus 1/2. So this 2 has been unaccounted for. And if we were dividing by 2x minus 1, we also would have to divide by this 2. And so far, we had just divided by this 1/2, which is right here. So the factor that you take out, you have to make sure you divide at the end. And that's why we do that additional step for a question like that. Okay, so my guess is you're probably going to come to the tutorial room and you're going to say, hey, I felt like that lesson was okay, but I did not understand example number 6. So that's probably the best explanation I can give of it, but I can talk about it again and maybe look at a different example with you guys. Example 7. We now have something in which we have an x squared minus 4. So just understand that if you wanted to solve this by long division, you could solve this by long division. You would have an x squared plus 0x minus 4 that you could use to divide. But we could do synthetic division for this question if it works out cleanly. And by working out cleanly, what we mean is it's going to produce a remainder of 0. It divides equally, so then we can continue to divide. And let's see exactly what that means when we set this up here. x squared minus 4 would produce x plus 2, x minus 2. And we're going to pick one of these two. Let's pick the x minus 2. If we were to divide by the x minus 2, we would have a 2 on the side here, and we'd be left with 1, 9, negative 5, negative 36, 4. As we do our synthetic division, we get something that produces a remainder of 0. Meaning that when we divided by x minus 2, it cleanly equaled something and gave us a remainder of 0. So we're left with, technically here, this would be x cubed plus 11x squared plus 17x minus 2. If you have a remainder of 0, that means that we've cleanly factored out that x minus 2. And now we have to just use the second factor, the x plus 2. And so to use the x plus 2, we would now put our negative 2 here, and you'd say, well, what are we left over with? We're left over with a 1, 11, 17, and negative 2. This is our leftovers. And when you do synthetic division a second time, we get x squared plus 9x minus 1 remainder 0. And that would be our best solution. So the question that you're going to say is, well, what would happen if you did this question and after the first step, you did not have a remainder of 0? If you don't have a remainder of 0, then you could try the other factor. And if that doesn't work, then it means you have to use long division. So if you're thinking back to the lesson, you're saying, can I only use synthetic division? The answer is no. Sometimes you have to use long division if synthetic division doesn't work out nicely. In example 7, it does work out nicely, but that's not always going to be the case. Okay, so here's our final example for the day. Let's set this up right here. We're dividing by x plus 1. And we have 2x cubed plus x squared minus 5x plus k. And it's saying find out what k is, but we know that we're going to be left with a remainder of negative 3. Okay, so think about what we could say with that. If we drop a 2 down here, we would get negative 2, add that, negative 1, positive 1, negative 4, positive 4, and then we draw this line here as we've done in the past. That's our quotient, but our remainder is negative 3. So what we've done is we've now created a statement here that's going to say k plus 4 is equal to negative 3, which means that k is going to be equal to negative 7. And you could do a check, you could try that out, and that's kind of an interesting way of being able to do that. Just as a note, it's an excellent way to do this, but the following class in section 3.4, we're actually going to learn another way to also be able to solve this. So here's your homework. Just as a heads up, some of the Michelson questions are a little bit challenging. You might hear me talk about that in class. Some of the long division questions right from the beginning are a little bit difficult. One thing that we'll add here is if there's any questions that have decimals, let's omit any of those questions for the time being. I don't think we need to go into that detail for today, but otherwise that's how you do long division and synthetic division with polynomials. Thanks.